Hey, what's up? It's your old pal, Mr. Cook. We're going to do the group worksheet for the probability test. So probability is kind of challenging in that if you notice, it's like all word problems. Right, so there's the potential for you to kind of overanalyze these problems, maybe think a little too much on them. So I'm going to try my best to simplify it as much as possible, but I want to reassure you that we are just scratching the surface for probability with this stuff, okay? So we're not going to be giving you like tons of difficult problems or anything like that. So like I'll stop with a couple of these problems and I'll say like especially like, 3E, I'll say, this one's way more difficult than something we ask on the test. So I just want to reassure you that some of these problems are a little bit even harder than the test, as with a lot of the group work stuff that we do. Anyways, so let's go through the basics. All right, so we start off with these probabilities. You have to understand what each of the symbols mean. The little U means union, so that's all of the elements that are, in A and B. The little N means the intersection, so the elements that are in both A and B, so just where they overlap or intersect, or where they have common elements. The little line means conditional probability. What that means is that it limits our subset to just specifically the values in B. This will limit it specifically to the values in A. So that's what conditional probability does. All right, so I'm going to go through probably the first three in this video and then kind of section it off based off of topic. So let's find the probability of A. We first have to understand the event A, which is the even numbers. So the even numbers are all taken from the universal set. So the even numbers from 1 to 10 would be 2, 4, 6, 8, and 10. So we have 5 numbers there. And then from B, it's the factors of 5. That's numbers that divide in evenly. The numbers that divide into 5 evenly would be like 1 and 5. That's it. We're probably going to change this for next year because if you notice, like there aren't any common elements here. So some of these questions are going to be really easy to answer as a result. Anyways, the probability that we have A, the evens, if we just pick a random number from here, there are 5 of those even numbers. So 5 out of the universal set 10. So that reduces down to 1/2. The probability of B, so the probability that if we pick a number at random from here that we get a factor of 5, there's 2 of those numbers out of the total of 10, so that's 1/5. The probability of the union, so I just look at the 2 different sets and I count up the unique numbers that I have. So 1, 2, 4, 5, 6, 7, 8, that's 10. That's a total of 7 numbers out of the 10. If they had any overlapping numbers, I wouldn't count those. If this was like magically 2, 1, and 5, I'd only count 2 once. So I'd have 1, 2, 4, 5, 6, 8, 10. So it'd still be 7 numbers. So, just watch out for like numbers that overlap. The intersection, well, just like what I said, there aren't any common numbers here, so there's no intersection, so 0. The conditional probability, the formula for conditional probability is based on the intersection of the 2 events. So like if that's 0, then, this is 0 too. Same thing with this, because the intersection is still going to be 0. Let me rationalize why that's 0. There's no common elements, so there's no way that you can get common numbers between A and B, so that's why it's 0 here. From this one, it says we start off with the numbers that are in B, so set B is the numbers 1 and 5. And of those 2 numbers, how many of them are even? None of them, so 0 out of 2, which is 0. This one says we're starting with the numbers in A, so we're only looking at the evens. And of those evens, how many of them are factors of 5? Well, the only factors of 5 are 1 and 5, and 1 and 5 aren't even in here, so that's 0 out of the 5 numbers, which is, again, 0. That's why we get 0 ultimately for those. For number 2, Joel rolls 2 fair dice at the same time. So dice have numbers, 1, 2, 3, 4, 5, and 6. What's the probability that he rolls a sum that is even? So I'm just going to imagine that I'm rolling some. I'm just getting an idea of the sample space. So if I roll a 1, then to get an even sum, then I'd have to add another 1 onto there to get 2. That'd be an even number. If I did 1 and 2, that'd give me 3, so that wouldn't work. So then 1 and 3 gives me an even number, 4. 1 and 4, that'd be odd, so I'd have to get 1 and 5. So 1 plus 1, 1 plus 3, 1 plus 5. Those will all give me evens. If I roll a 2, I'd have to get a 2, a 4, or a 6 to roll even sum. And then for 3, I'd have to roll a 1, a 3, or a 5 to get an even sum. You start to see a pattern. For each one of the numbers that I roll, I get 3. So that means there's a grand total of 18 total numbers that would add to an even number. So that'd be 18 total numbers that add up to evens. And then out of a pair of 36 numbers that you would get from the total sample space. The reason I get 36 is because for the first roll, I'd have 6 options. For the second roll, I'd have 6 options. So if I multiply those together, I get 36. That's where I get the 36 from, over there. And then this 18 over 36 reduces to 1/2, and that's my probability. Moving on. So what's the probability he rolls a sum of 7? So the numbers that add together to be 7 would be like 1 and 5. Oops, sorry, 1 and 6. Jeez. 6 and 1. 2 and 5. 5 and 2. And then 3 and 4. And 4 and 3. So that's 6 options out of a total of 36 that add up to 7. So that reduces down to 1/6. So that's my probability. All right, now moving on to the standard deck of cards. So you need to know a little bit about cards. You know, there are only 2 colors in the cards. That's black and red. There are a total of 52 cards. 26 of them are black, 26 of them are red. And then amongst the colors, there are different suits. So the black cards are broken up into 2 different suits, the spades, which are black, and then also the clubs that are black. And then for the red cards, there's the hearts and the diamonds. So there's even amounts of spades and clubs. So since there's 26 black cards, there's 13 spades and 13 clubs. And then for the 26 cards that are red, there's 13 hearts and 13 diamonds. You can get a little bit more specific from there as well. I mean, I don't want to get too involved with that. You can Google, you know, like standard deck of playing cards and see all the different things that are in there. Anyways, so this is kind of an idea of our sample space. From a standard deck of cards, what's the probability of drawing a red card? There are 26 red cards out of a total of 52 cards, and that reduces down to 1/2. And that should make sense because half the cards are red. What's the probability of drawing an ace or a black card? Well, there are 4 different aces. There's an ace of hearts, an ace of diamonds, an ace of spades, and also an ace of clubs. And then black cards, there's a ton of black cards. There's 13 spades. So there's the ace of spades, the 2, the 3, the 4, the 5, the 6, 7, 8, 9, 10, then the jack, the queen, and the king. And there's also the clubs. And that has an ace, 2, 3, 4, 5, 6, 7, 8, 9, 10, and then a jack, a queen, and a king. So or means that we're doing the union. So that's all the cards. So if I get an ace, that's a successful probability. Or if I get a black card, that's a successful probability. So let's just count up how many successful cards we could get from this probability. There's 4 here, so 4. And there's 13 here and 13 here. But if you noticed, we have an ace of spades already. So we don't want to count this one. So we're going to erase that one. We don't want to count it twice because there's not 2 aces of spades in a standard deck of playing cards. Then we have the ace of clubs already counted, so we don't want to count it twice, so we erase that one too. So that means we have 12 cards here and 12 cards here. So if I add all those up, 4 plus 12, that's 28 out of a total of 52 cards would give us a successful probability here. Excuse me. So then 28 and 52 are both divisible by 4. So that means this probability reduces down to 7 over 13. And that's our answer. All right, so that's A and B. Now let's move on to C. What's the probability of drawing a red king given that it is a red card that's drawn? So this part of it right here tells us that it's a conditional probability and it limits the sample space. So if it says given that we're dealing with a red card only, there are 26 red cards. Of those, how many are red kings? Well, there's going to be a king of diamonds and a king of hearts, so there's 2 of them. And that's our probability, and it reduces down to 1 over 13. So there's our answer. Now, 3E would be a problem that I would say is a little bit too difficult for the scope of a test, especially one where we're just, going through the basics of probability. Because this one says 2 cards are drawn at one time, at a time without replacement, so the cards aren't replaced back in there. What's the probability of drawing a 4 and then a heart? Well, it's kind of 2 different situations here. One, in which you get any of the other 4s, like the 4 of diamonds, the 4 of clubs, or the 4 of spades on your first draw. And then on your second draw, like if you don't get the 4 of hearts, then you have 13 different hearts that you could deal with, like the ace, the 2, the 3, 4, 5, 6, 7, 8, 9, 10, jack, queen, and king. So that would be like one probability where like I get one of these 3 and then get one of these. The other one would be getting the 4 of hearts on the very first try. So that would be a 4, so that would be the successful part here. And then the second one would be another heart. So if I already drew out the 4 of hearts and I don't replace it, that means that I've got the ace, the 2, the 3, the 5, 6, 7, 8, 9, 10, jack, queen, king. So 12 of those cards. So these are 2 different situations, but together they make this total probability. So I need to take both of these probabilities and add them together. So, these are split into 2 events, drawing the first card and drawing the second card. So I'm going to use the counting principle to multiply these together. And same thing for these 2 events. So let's multiply the probabilities. Let's find the probabilities first. So if I draw out the first card, it should be one of these 3 4s, right? So that's a total of 3 cards out of 52. That's on the first draw. On the second draw, I have all 13 of these cards to, potentially get. So that's 13 cards, 13 hearts out of the 51 remaining cards, because it's 51 now because I took one of those cards out and didn't replace it. All right, for the next one. The next case is that I get exactly this card. So there's only 1 4 of hearts in the entire deck. And that would get me this, this other part of the probability. Because then what happens is that once I get that 4 of hearts eliminated from, the deck, that means that out of the 51 cards, I have now 12 hearts to pick from. So I need to multiply these probabilities together and these together and then add them to get my total answer. Let's see what that's going to end up being on our calculator. So 3 out of 52 times 13 out of 51 plus 1 out of 52 times 12 out of 51. Okay, we get that, and then we just go ahead and convert it to a fraction, and it's just 1 over 52 when we add them all up and add. Isn't that cool? 1 out of 52, that's our answer. This would be one where it'd be like a little too much of a challenge for you guys. So, if you see card problems on the test, just expect ones of this difficulty. If you didn't have any problem understanding 1, 2, and then 3, A, B, C, you're doing pretty good on this stuff. If you are still struggling, just make sure you come in the morning and see your teacher and get some help. All right, that's it for this part of the video. I'm going to go ahead and do the permutations and combinations next when it's asking for the number of arrangements. All right, that's it for this one.